the two sets of code for robot A and robot B, and they're identical. Clearly, all of those things could have been parameterized.
Suppose you are given a corner case of configuration where most of the work is sowing and there is only one weed. The other robot is a bit wasted, so there is some scope for distributing the workload between them if you had a common mechanism. There is the physical reality of your robot moving on the arena. This abstract web server view of what is happening. Physical reality can sometimes be very different from what is shown on the web. You try to drop a seed and it falls out of the basket. What does your web server do?
It will show as sowing done.
Partial abstraction. Once it's attempted to drop, it is dropped. It resumes that. Something for you to think about.
Did you think of a different way of solving the problem? And that different way being devising a mechanism which can pick several things at the same time. That means pick 1, pick 2, pick 3, pick 4, and then go and drop.
You have things like lightweight processes, pattern matching, fault tolerant supervisor, that kind of behaviors. So if you look at asynchronous programming, JavaScript has WebSockets and asynchronous programming. It's not a functional language. The style of messaging can be handled in any of these languages. In JavaScript, there is a different way of writing asynchronous code they call callback hell, which is you have a function that catches the callback and then it completely inverts the whole way the control flow goes. In a actor-oriented language, it's much easier to handle because you have different actors sending messages to each other and each actor can actually block synchronously. So that's a facility that you don't get in any other language. You only get it in Erlang preemptively. Erlang Elixir.
Definitely the IEX command interface and the pipe operator.
Python has IPython, which is even better than IEX.
And using agents as an abstraction over the GenServer to store state as opposed to global variable.
So what is the pipe operator in Elixir?
The pipe operator allows the output of one function to be sent directly to another function without wrapping it around in code. So that helps in making the code easily readable and also gives a logical sequence to the flow of your thoughts when going through it.
It's composition of functions.
Sure, what composition of functions is?
It's a diamond in Haskell. You could have a very simple heuristic like the one with the smallest ID, A, gets its way and the other defers. If you're doing path planning for the next task, you have task planning and then path planning. The next thing I'm going to do is either seed or weed, depending on whatever is closest to me. And you can communicate that with the other as long as they're not getting in each other's way. They can independently do whatever is nearest to them. That's like a greedy algorithm. It just finishes whatever needs to be done closest to it, for example. It goes task by task. So you have most of the algorithm already there. You just have to check with the other one and break ties. You do an agent.get by name, which is no different from a shared structure. There's a single instance of it. Everybody is doing agent.get. No reason why you can't do it in any other language. So how is an agent different from a global variable? Any other language that is single threaded. At any time there is only one caller, only one is updating it. Somebody changes it, nobody else is changing it unless you have a multi-threaded system. Within a single Elixir process, you have multiple logical Elixir processes that are preemptively threaded. With an agent system, you can do a whole lot of changes all at one time atomically. You can say change this, change this, change this, change this, because it's all part of one function. And you say make all these changes all at one time. If you have the same thing split over multiple global variables, it's possible that one process is changing a couple of variables, other is changing some other variables. You cannot have all of them consistently done at the same time. That's what Elixir gives you. Speed and direction are the two separate variables. And there are multiple clients saying you change the speed and direction to this, and another client says you change the speed and direction to something else. Now it so happens that these two clients are actually fighting the state to get there first. This is called a race condition, right? Now it is quite possible that these two clients end up changing in opposite days. So client A says I'll change the speed to speed A and the direction to direction B. Client B says I'll change the speed to speed B and the direction to direction B. But the end result of it could be, depending on how it was done, the speed is speed A and the direction is direction B. The two different variables got affected differently. So it is not consistently changed. What an agent architecture gives you is that at any point, all variables will get affected by only one client at a time, only one request at a time. Similarly, when somebody does an agent.get, they will all get a consistent snapshot. A consistent snapshot meaning all variables have been affected by the last client that updated that state. They will get that state. So there's no confusion about some things being modified by somebody, some other part of it getting modified by somebody else. This is the kind of thing that you get in databases. What is called a consistent architect, consistent snapshot, or a transaction is what it's called. In other terminology, like Kavi was saying, this is called an atomic property. The changing of all state is atomic. Either all of it happens or it doesn't happen at all. You never see partial updates from flight A or partial update from flight B. Elixir allows you to do it very, very easily. So instead of having local state, you maintain the state in the server. So if one of them discovers an obstacle, it's immediately known to the other one also. Immutability is used in architectures. It's not used in languages so much. Whether you look at the design of a flash chip where nothing is overwritten, right? Everything is allocated to a new flash page, flash memory. Or if you look at the internals of Linux, there's a whole lot of things that are not overwritten. If you look at any modern databases, they are all multi-version databases. Nothing is overwritten. Existing data doesn't get overwritten. So concepts that you will learn in a functional language, actually you will see actually applied in larger systems. If you look at all of Facebook's architecture, it's actually fully functional because nothing is overwritten. That is why you can have a history of things. It is never overwritten place. So keep that in mind. The moment you move to some other language, you will feel the lack of it. That you have these little tasks that are preemptively operating on their own and they're able to communicate with each other. That is a luxury that you get only in Erlang and Elixir. Unfortunately, you don't get it in any other language. Preemptively scheduled small tasks. Everybody has used this notion of process.sleep, that every little process waits for some arbitrary amount of time for a message. And that's hard-coded, like 50 milliseconds, 100 milliseconds, something like that. If you have to wait for a timer to sleep, if you are arbitrarily waiting, that's an anti-pattern. What you're essentially waiting for is a message saying, do this. And Elixir gives you that. Erlang and Elixir both give you that. And you can just wait for a message. And waiting on the appropriate message, then you don't have to hard code any time. If the time is too big, then you're waiting unnecessarily. If the time is too small, then you're just spinning around, most part, doing nothing, and battery is getting wasted. So if you're using process.sleep, you're doing it wrong. There's too much code that is quite repeated. Whether it is robot A and robot B, whole chunks of code that is unnecessarily repeated. In fact, I did a diff. I just changed A to B in some code and it's almost identical, right? Completely unnecessary, except for the sewing and weeding part of it, which is different. And also repetition I see in directions, like move right versus move left or turn right, turn left. They ought not to be different. They are just parameters. Functional programming is all about functions. So as far as possible, try to develop your system. When you have a function, it is free of side effects. That function cannot call agent.get or agent.set. It is given to it as a parameter so that it can do whatever it has to do, compute, and return the result. Easiest way to figure out if you're doing it right is to write tests for it. When you have functional code, the testing becomes very simple because it has no side effects. You can call it a million times, it has no side effects. So you can call it with different parameters and you check to see in the testing code, you check to see whether the function did the right thing. If you have a function called turn right, it could come back with a series of instructions saying the PW must be set to this, it should be operated for this long, and so on. All it is doing is giving back a set of instructions to a different module saying turn the motor on for this long with this frequency or whatever be the parameters. So the turn right function actually does not turn the motor. It merely creates a list of things to do.
Erlang shields you from the nitty-gritty of the problems that could happen in concurrency and makes it easier for a novice to dabble in this space. right? Where otherwise you'll have to know much more about concurrency and the problems and scheduling issues and stuff like that. A language called Lustre, in which you are given a certain timing model, means a certain way that you should be thinking about the problem. And then Lustre gives you a very nice way of actually expressing a solution. Languages like STRL and stuff like that, where the compiler is doing all the scheduling and all that kind of nitty-gritty.
You should think of building such solutions in a kind of component-based way. Suppose you have a path planning algorithm, the basic code that you write, can you actually parameterize it in such a way that later when you have to modify it, add obstacle avoidance into it, do replanning of the path in presence of obstacle, you can dynamically do it without having to completely rewrite the code. If you produce a solution for 2 robots, perhaps it should be written in such a way that it can generically be extended to, let's say, K robots trying to cooperatively solve the problem. When you build things using components, you have many options of how to combine them. So there are design trade-offs here. And then you have to think of optimality. So I think when you design, you should have a mentality to explore the design space and choose the more optimal of solutions.
Every single packet in the internet goes through a router that uses Erlang. It's controlled by Erlang. So every Cisco router has Erlang.
The entire WhatsApp system has been built in a functional programming language. Ericsson has been building switches and routers based on these kind of languages. And there are a vast number of systems and even the cryptocurrencies which are based on a functional programming paradigm. This belief seems to be there. If it kind of works, it's good enough. Now, would you ever buy a mobile phone that kind of works the way you guys build your hardware? And getting to that point where it works 100%, whether it's your program or whether it's your hardware and all that, it requires relating to engineering slightly differently. You have to invent problems that it can encounter and solve those things also. You have to anticipate things that can happen, solve those things also. Thank you for having spent the amount of time that you did over the last 6 months to get to this point. And I think all of you deserve a pat on your back.